And now we move on to the next topic, force and motion, wherein we look at how force applied on the object or forces applied on the object will affect the object's motion. In this video, we cover Newton's laws of motion. First, what is this force that we speak of? Put simply, a force is a push or pull influence that can change the state of motion of an object. For now, for the time being, when we say state of motion of the object, we're basically talking about the position and velocity of the object. So a force is an influence that can affect the position and velocity of the object. There may be more than one force applied on an object. The object will behave according to the net force. Net force is the summation of all the forces acting on the object. For instance, in this figure, you have an object, a bust, and three forces are applied on the object. You have F1, F2, and F3. The net force experienced by the object, F net, is just equal to F1 plus F2 plus F3, the summation of the three forces acting on the object. And the unit of force, not just net force, but unit of force itself is Newton, capital N. 1 Newton is equivalent to 1 kilogram meter per second squared. We also have the dyne, which is equal to 1 gram centimeter per second squared. And since force is a vector quantity, it has magnitude and direction. Be sure to use your component method when analyzing forces or when adding forces together, as in the case of determining the net force, summation of all the forces acting on the object. So again, force being a vector quantity, be sure to use your component method when analyzing forces together, when analyzing forces or when adding forces together. There are three laws of motion according to Newton. First, let's have the first law of motion. If no net force acts on a body, the body's velocity cannot change. That is to say, if the net force is equal to 0, the velocity of the object is constant. This implies that if the net force is not equal to 0, the velocity of the object is not constant. In our kinematics, we covered how the acceleration is the rate of change of velocity with respect to time. If the acceleration is 0, the velocity is constant. If the acceleration is not equal to 0, the velocity is not constant. That means there's a relationship between net force and the acceleration of the object. If the net force is equal to 0, the velocity is constant. That means the acceleration is equal to 0. On the other hand, if the net force rather is not equal to 0, the velocity is not constant. That means the acceleration is not equal to 0. So if F net is equal to 0, acceleration is equal to 0. If the net force is not equal to 0, the acceleration likewise is not equal to 0. The acceleration experienced by an object depends upon the net force acting on the object. The second law of motion gives us the relationship between the net force and the acceleration. For constant mass, so m is equal to constant, the second law of motion tells us that F net is just equal to mass times the acceleration of the object. The acceleration experienced by the object is proportional to the net force acting on the object. The net force produces the acceleration experienced by the object. Lastly, we have Newton's third law of motion, also known as or also referred to as the law of action and reaction. For every action, there is an equal but opposite reaction. F reaction is equal to negative F action. For instance, say you have a cart being pulled by a horse. The horse pulls on the cart, F action. The cart will react by applying force, F reaction on the horse, equal in magnitude to the F action, but opposite in direction. In this figure, at least, F action is applied by the horse on the cart. F reaction is applied by the cart on the horse. So action is a force, reaction is a force. F action, you have F action. Reaction, you have F reaction. Now, it's very important to note that even though these two forces are equal in magnitude but opposite in direction, they do not cancel out. This is a very common mistake or misconception of the third law of motion. If the horse was to pull the cart with F action, the cart pulls on the horse with F reaction, and they are opposite direction, equal in magnitude, you might be tempted to think that they cancel out, and no matter how hard the horse pulls the cart will react by pulling with a harder force. The cart will not move. The horse, no matter what the horse does, the cart will not move. This is a common mistake in terms of Newton's third law of motion. They do not cancel out because they are applied on two different objects. Forces will only cancel out if they are applied on the same object. F action is applied by the horse on the cart, so it's applied on the cart. Whereas F reaction is applied by the cart on the horse, so it's applied on the horse. So the two forces are applied on two different objects. They do not cancel out. So again, Newton's third law of motion, for every action, there is an equal but opposite reaction. And that's it for now. In the next video, we'll take a look at the different types of forces that you are likely to encounter in your study of basic physics. So again, that's it for now. Thank you for watching.